Here we have is a piecewise defined function f of x, and this one has three parts to it. So looking at each part of the formula, we have x plus 3, 5, and then negative x plus 2. Okay, we have our three different if statements, and so we're going to go ahead and follow those along for the next part, which we're going to find the value of f at negative 1. So remember, we're going to use the if statements to tell us which formula I'm going to use for that value. So I'm going to check the statements to see if it gives me a true statement. If it gives me a true statement, that's going to be the only place it's going to work for. If you check it for the other if statements, you should get false statements. So once you get a true statement, you're actually able to just be finished. But I'm going to continue and show you how you're going to get false statements for the other if statements. So for the first if statement, plugging in negative 1 for x. So for that, I'm going to plug in negative 1. We have negative 2 less than or equal, plugging in that negative 1 less than 1. So when I look at the statement, is negative 1 between negative 2 and positive 1? Yes, so it gives me a true statement. And technically you could stop there. Once you realize it gives you a true statement, you're done. But I'm going to follow through with the other ones just to show you you're going to get false statements for the other two. So again, plugging in for the x in the if statement, I'm going to get negative 1 is supposed to be equal to 1. This comes back as false. Same thing, I'm going to plug in negative 1 into the x value there. So negative 1 is greater than 1. Again, another false statement. So the only time it's true is for this if statement, which means then I'm plugging into this formula. So f at negative 1 is equal to plugging in negative 1 for x plus 3. And so we have it's 2. Okay, now we need to sketch the graph of f. So we go sketch the graph. So I'm going to create my axes because for some reason I don't have one. Okay. And we're going to go ahead and see that, straighten this out a little. There we go. So we're going to go ahead and use the if statements to help guide us to create the graph. Now, looking at each part of the function, I'm going to kind of give myself an idea of what I should expect for each part of it. So for the first one, x plus 3, this is an equation of a line. So the way it should look when I have it is going to be on its own domain and everything, on its full domain, is going to be a line. Now, that's just my axis. The line, because the coefficient on x, that's my slope, the coefficient on x is technically a 1, it's an unseen 1, it's positive. So that means I'm going to have a slope going upward. It's a positive slope. Okay. For the next part, this 5, that's our constant function. That means I get a horizontal line on its full domain. So on its full domain, I get a horizontal line at 5, at y equals 5. And on the last one, this, again, is an equation of a line. And since its slope is negative 1, that means I have a negative. So I have this part. It gives me a negative line, so a negative slope. So it's going to be going downward from left to right. So that's what I can expect from each part when we're just talking about them individually. So not as if, just to give me an idea of what I can expect of the shape. Now, because each part now has a restriction, we have to consider the restrictions when I actually go to graph it. So when I go to graph it on here, I have to keep in mind the restrictions. So let's go ahead and put our tick marks in. I believe you have in your book, you guys all have the grid already provided. Somehow it just disappeared on my book. So putting in those tick marks so everyone can see it. All right, so it's not going to be as perfect, but oh well. So first off, notice I have a starting point and an end point for my line, my first formula here, first part. So I'm going to use those to guide me through that. So those are going to be starting and stopping places. So we're going to have, I'm going to plug in for f at -2. I am going to plug in -2 into that first equation. And it comes back as 1. Now, when I look at it and I consider, so -2 is less than -2 is greater than 1, I get back a true statement because -2 is less than or equal to -2. So because this is true, I'm going to be able to have a closed circle when I go to plot it. Okay, so for this point, -2, 1 is closed. Then I look at plugging in 1. So the other endpoint of that restricted domain. So again, -2 to 1. Okay, so now I'm going to plug in the 1. So that's 1 plus 3. So that I get back 4. So I have the 0.14. And when I check to see if this -2 less than or equal to 1 less than, just less than 1, 1 is not less than 1. So this gives me back something that's false. So this is going to be open. It's going to help guide me, but it's not an actual point on the graph. Okay, so I'm going to use an open circle on that one. Okay, so let's go ahead and plot just that part. So closed on -2, 1. And then we have an open circle at 1, 4. And like we said, this is a line. So I'm going to draw a straight line between the two. Be careful to not assume that you're always going to get, it's always a line. That's, I see a lot of students that will they'll get their two endpoints and it's actually like a parabola or something between them. So you have to go to those other points and create the parabola shape. So you have to be careful. It's not, that's why I'm saying these will guide us. When I draw these ones out, this guides me to what's the shape I'm going to be dealing with for this part. Okay. The next one, this one's interesting because in its if statement, it has an equal sign. It's only one value that it's true for. Whenever it has an equal inside the if statement, this is a single point and it's going to be closed because we're going to plug in 1. 1 does equal 1, so it'll be fine. So this is our single point. So that means at f equals 1, or f at 1, sorry, this is then just 5. So I have the ordered point 1, 5, and like I said, for that if statement, 1 is equal to 1. So when I plug in 1, I get that this is true, and so it's closed. It's a closed circle there. So we're going to go ahead, 1, 5, right there. Okay. And at this point, I didn't put -2, 1. There we go. All right. Now notice I don't label this open circle because that point doesn't actually exist there. It's an open circle saying that the line is going towards it and getting infinitely close, but never going to actually reach that point. Instead, the value of the function exists here for 1, so it's equal to 5. Okay. The next part. So I have f. So again, using the fact that it starts at 1, that's what I'm going to do. I'm going to plug in 1. F at 1 is equal to, so we have negative, plugging in 1 plus 2, so that gives me back 1. So I have the point 1, 1. Okay, and so from there, we look at the statement. So we see if it's true or not. So is 1 greater than 1? Well, this comes back as false. So this is going to be open. I'm going to use an open circle there. So that means at the point I have is, so I, before I plot that, I need another point actually. I need another x value, anything greater than 1, so that I get a true statement. So that when I plug it in, I get to have 2 points. So right now I have this 1 point like right there, but I need another point somewhere down here that's going to be able to allow me to connect them. So we're going to go ahead and get another point. So plugging in, let's say 3. F at 3 is equal to negative 3 plus 2 equals then negative 1. So I have 3, 1 is my ordered pair. Then noticing again, we chose the x specifically so we get a true statement, and so we do. So this is a closed point. Okay, so I have the point, then 1, 1, which is right there, open, and then 3, 1, which would be right there, or 3, negative 1. Forgot that negative on there. So 3, negative 1, which would be about right there. And now looking at my if statement to see, do I have an ending point on the other side? I don't. So I'm not looking for it going up to a certain point. So x can go off to infinity. And so we just draw the line continuing beyond that point of 3, 1 with our arrow to indicate that it continues. And so now this is our 3, 1 point, or 3, negative 1, sorry. And so we have now our graph. All right. To find domain and range. So for domain, so is the union of the if statements. Okay, so we're going to just kind of union them all up. So each of them is, so I have from negative 2 up to 1, not including. Then I include 1. So now I'm going from negative 2 to 1. And now it says for anything greater than 1. So that means I'm going to go from negative 2 to anything greater than negative 2. Right? And so that's what it is. It's going to be anything greater than negative 2. So basically, and you can look at the graph and see that we're looking at the horizontal value. So I'm going from negative 2 and I continue and I continue and I continue, and it's continuing that way. So we have negative 2 to infinity is going to be my domain. Oh, negative 2, sorry. Negative 2, and I get to include it. Should have said that. It's a close, so I'm including it because it's closed. So negative 2 to infinity. There we go. All right. Then looking for the range. The range you have to read off of the graph. Okay, so we have to read that from the graph itself. We don't have another way. So once you have it graphed, remember, range means I'm going from here, down here is a negative infinity, so I'm going to talk about going upward. Right? I always start with smallest to largest. So notice that this side, this arrow indicates that I'm going down to negative infinity as x is going to positive infinity that way. Y is going down to negative infinity. So I'm going to go ahead and start off at negative infinity. That's where I'm going to start. I'm going to continue this upward. And I can see that that on the orange or yellow, whatever you think it is, I have a stopping point here. But it continues with the green. So the green will continue going upward up to a spot here. So at 4. From there, from this place here all the way up, we then have a gap. Do you see the gap between 4 and 5? Remember, we're looking at these values, the vertical values, y values. We have this gap. So that means this one here, right? there's a gap. So I'm not going to say I have from negative infinity up to 5, but I have actually from negative infinity up to 4, and then I have 5 included. So let's go ahead and write that out. So it's negative infinity up to 4, not including because it's open at that value. And then we're going to union, and we can then just put 5 like that. And there we have is our range.